Today's October 20th, 2011. We're going to go over line of best fit, which is lesson 3.3. Okay? So going over lesson 3.3. We have a graph here. The y-axis represents the hour of homework per week. So this would be 10 hours, 9, 8, all the way down to doing no homework per week. The other x-axis, and you know what? I'm sorry. I've drawn this back. All right, so we corrected our mistake. Or my mistake, sorry, not yours. Our independent variable, which is our hours, so the amount of hours we do of homework essentially determines the grades we're going to be getting. I want an outlier here. Okay? So our independent variable is going to be put on our x-axis. That's the amount of hours of homework we do. And our dependent variable, the grades, goes on your y-axis. So always remember, independent goes on the x-axis. Dependent variable goes on the y-axis. Now, let's try to make sense of what these points along this graph mean. If we had this individual here, okay, talking about this guy, it says here that he does a little over 8 hours of homework a week, and his grade is roughly 79, 80%. Okay? Next guy up here, looks like he does about almost 10 hours of homework a week, and he probably has roughly a 95, almost 100 in the class. No, he's smart. Next guy here. He does about an hour and a half of homework a week. He's getting 30%. Okay? 3 hours of homework a week, 40%. It almost looks like the 4 hour a week mark kind of gets you to a pass. Okay? Now this is just data we collected. This isn't true by any means. It's probable, and if I can say it's very probable, but people looks like who do a little more than 4 hours a week seem to be passing. They're getting at least over 50%. Anyone who's doing less than 4 hours a week seems to be in the failing part of this imaginary class. Okay? So, what we're trying to create here, now sorry, there is one thing. We need to create a line of best fit. Does anyone know where the line of best fit would probably go in this? All right, I'm going to move the line. This is going to be like that Price is Right game. And everyone needs, when the noise kind of gets the loudest, you can tell me when to stop, okay? Line of best fit. Stop! All right, he feels pretty confident there. That's probably a pretty good estimate. We might even want to bring the slope down a little and bring it up a bit.
We can't control that. That was your fault.
Okay? This is roughly a line of best fit. Okay? Because if you notice, all the data here falls either a little below or a little above the line. So this line is roughly a good representation of how many hours of homework someone would do in a week compared to their grade. So like we said before, remember the 4 hour mark? It looks like after 4 hours, most people would be passing if they did more than 4 hours a week of homework. So that's about an hour every night. Actually, it's less than an hour every night. Anyone who's doing less than that in this imaginary class,
So I think if you do any homework,
it looks like they'll be failing the course. And if you're doing roughly 10 hours of homework a week, it looks like you'd probably get roughly 100% on the course. Now, there are the odd people
you do no homework and pass for 3 years.
getting 2 hours, we'll say about 3 hours of homework, and they seem to be getting an 80. Does anyone know what that piece of data would be called, Alex? Yes, that's an outlier. Okay? So this outlier doesn't quite fit with the rest of our data. Doesn't mean it's not true. That means the person who ever collected this data, they found that there was one person in the class who only needed to do 2.5 hours of homework and they got an 80. But for the majority, or everybody else in the class, they all fell somewhere along this line of best fit in terms of their grades compared to their homework. Okay, example 2. This is a graph of fuel consumption on a car. Okay? On our x-axis, we have the independent variable. Okay? This is kilometers per hour. So this is how fast we're going, our speed in the vehicle. And on our y-axis, we have how many kilometers you get, so your distance per liter. So this is how many kilometers you travel per liter of gas in your car, depending on your speed. So, first off, if you've noticed, I have a broken line to start the graph. What that means is I'm going to go up by a certain increment, but the very first one I went up by won't be the same as the rest. So if you notice, I went from 0 to 40. I put that broken line there because after that broken line, I went up by tens. Okay? You can do that on a graph, especially if you need to get up to a number quickly and all the data seems to be around 1 point. Okay? So this is roughly a pretty accurate representation of cars on the road today. It's probably really good for my truck that I drive. So, if you travel at roughly 40 kilometers an hour, you're only going to get about 2 kilometers per liter of gas. Kind of getting screwed, okay? Cars become more efficient up to a certain speed of roughly 80. Now, it depends on what car. We're going to say this is my truck, okay? Around 80 kilometers an hour, my truck is roughly the most efficient it can be. It gets 9 kilometers per liter, or around 10. Okay? That's actually probably dead on almost. So if I travel for the whole 55 liters that my truck holds at 80 kilometers an hour everywhere, I will get the most fuel efficiency in my car. Once I start passing 80 kilometers an hour, my car becomes less efficient. I start getting less kilometers per hour. Less kilometers per liter. Okay? So what we need to do is we need to create a line of best fit. And if you guys notice, our line of best fit, again, is probably just going to run through the middle of this data so that we have points that run above and below it. See if I can use this tool for it. I'm not talking about you guys. No, that's not that great. Let's just do it in red. Here's our line of best fit. According to this, if I go over 130 kilometers an hour, my car will drink the gas so fast I can barely get a kilometer, which doesn't make sense, but this is roughly our line of best fit. If you notice, all our data that we found lies either above or below this line of best fit. We don't have any outliers in here. We're going to say that the car is built pretty well, so there are no outliers. Every time I recorded how fast or how far I got per kilometer at a speed, I landed roughly around this line of best fit. Now, what I want to compare is our first line. What type of equation or function is this? Linear. That's right. We have a straight line. This is a linear function. So apparently the more hours we spend studying, the greater our grades got. What type of function is our second graph? It's definitely, yeah, you're right, it'd be irregular to linear, but we've done functions like this in grade 11, grade 10. Quadratic.
Yes.
This is quadratic. This looks like an upside down parabola. So this one is quadratic. What it's telling us is that at one point it reaches our vertex, which is our peak. That's when our car is most efficient. And then after that, our car starts becoming inefficient again. Or inefficient, not inefficient.